Hello, my name is Z Keefe, and today I am presenting my capstone study related to occupational zinc chloride fume exposure in a steel galvanizing plant. In addition, a proposed engineering control system is presented, along with industrial ventilation calculations required for system losses and required airflow. The purpose of this study is twofold. One, to assess worst case scenario zinc chloride fume exposure in a hot dip zinc galvanizing plant during normal operations through the use of area air samples, and two, to utilize the ACGIH industrial ventilation equations to design a proposed exhaust and filtration system as a solution to reduce zinc fluoride fume emissions. In order to do this, full shift time-weighted average samples for zinc chloride were collected over 3 days using personal sampling pumps at 7 worst-case scenario locations. Bayesian statistical analysis with a 70% confidence interval and 30% risk tolerance calculated the 95th percentile, exceedance fraction probability, and point value. The engineering control proposed is a combination of a kettle enclosure and baghouse filter system. Given proper design, this system will be effective in capturing zinc chloride fume at its source. The galvanizing process involves treating steel pieces with a flux material containing zinc chloride and dipping into molten zinc. The heat from this zinc bath reacts with the flux material to create zinc chloride fume. Studies have found that zinc-based toxicants can affect memory and mental capabilities, can negatively affect thyroid function, can cause a high prevalence of metal fume fever, and reduced copper and calcium levels in the blood. It has also been found that zinc inhalation affects cellular immunity and tryptophan degradation. Irritation of the respiratory tract, acute respiratory disorders, chronic respiratory conditions such as chronic bronchitis, persistent shortness of breath, and asthma-like symptoms have also been associated with zinc exposure. It can also cause immunologic effects, neurological symptoms, and system toxicity. In severe cases, it can cause pulmonary edema. The galvanizing plant facility is a steel and fiberglass panel structure with an approximate footprint of 58,300 square feet. The open portion of the building in which much of the galvanizing activities take place is one large room with a high-pitched roof, which is approximately 25 feet. No local exhaust ventilation was in place at the time of the exposure assessment. 10 rooftop exhaust fans and 4 fans on the southeast and northeast portions of the facility provided some general ventilation in the area where much of the galvanizing activities take place. These fans were operational at the time of sampling. Samples for zinc chloride were collected on 0.8 micron cellulose ester membrane filters using personal sampling pumps set at approximately 2 liters per minute. The samples were analyzed by a modified NIOSH 7301 method. Laboratory analytical results show that virtually all of the zinc chloride fume samples exceeded the occupational exposure limit. Zinc chloride fume sample concentrations ranged from below the laboratory's limit of detection to as high as 3.8 milligrams per meter cubed, with the average concentration being 1.57 milligrams per meter cubed. The OSHA PEL, NIOSH REL, and ACGIH TLV for zinc chloride is 1 milligrams per meter cubed. Using a two-sided 70% confidence interval, we find that the risk that the exceedance fraction is greater than 5% is 100%, which is obviously higher than the 30% risk tolerance. If these values are analyzed statistically based on repeating the process multiple times, the exceedance fraction point value is 52.1%, with a credible interval of 47.5% to 56.8%. These results show that in many situations, workers are exposed to concentrations above the OEL. In order to capture zinc chloride fume at the source, a proposed engineering control solution is provided. This system involves a steel kettle enclosure system that is ducted to a bag filter system and is subsequently exhausted above the roof. In order to do this, it was necessary to obtain specifications related to the exhaust duct exiting the kettle enclosure. We found this information by finding a specification in ACGIH's Industrial Ventilation Handbook. The specifications call for a minimum duct velocity of 3,500 feet per minute and states that the hood entry loss coefficient is 0.25. With this information, and assuming a 12-inch diameter duct, the flow rate of 2,750 cubic feet per minute of air can be derived. After obtaining this information, we found equations that were then used to calculate the system losses. These equations are those presented by ACGIH in the Industrial Ventilation Handbook. In the end, using these equations, it was determined that the design required a total airflow of 30,404 CFM and presented a pressure loss of 6.7 inches water column. This information can be used to size the motor and select the appropriate type of fan. Through this study, it was discovered that the hot dip galvanizing process produces a high concentration of zinc chloride fume as a result of flux bath material being introduced to elevated temperatures. These findings suggest that, depending on a variety of variables including temperature, airflow, humidity, and the like, workers may at times be severely overexposed. It was also made apparent that there is a gap in the literature related to zinc chloride. Whereas many studies focused on zinc or zinc oxide, very few to no studies in steel galvanizing plants were found that dealt specifically with zinc chloride fume. The risk of overexposure can be mitigated, it has been found, through the design of an effective enclosure and filtration system. The installation of such a filtration system will bring the company into compliance with occupational regulations and will allow management to operate according to state-of-the-art industry best practices. Ethical considerations were at the forefront of this study as worker exposure and their well-being was placed as paramount. Going forward, it is recommended that additional studies be performed related to zinc chloride in steel galvanizing plants and that older facilities be updated in order to better protect worker health.